In this example, we're looking at a set of police records that were pulled for larceny thefts. So we have a police officer who randomly selected 642 records for larceny thefts, and you can see each of the categories listed there. We're being asked to construct a probability model for the type of larceny theft. Now, what we are looking at currently, if we want to think back to a previous chapter, chapter 2, is a frequency table. Remember, a frequency table tells me the frequency with which my category occurred. So in this case, if we look at pocket picking, we can see that the frequency that we had pocket picking was 4 offenses, purse snatching 6 offenses, and so on. So what we're really looking at is a frequency table, which we've discussed previously. We know that we can take a frequency table and we can turn it into a relative frequency table as well. Relative frequencies are the number of occurrences divided by the total number in our table that we have here. So I'm going to put another column over here on the right-hand side. I'm going to label this the relative frequency column, and we're going to look at how to calculate relative frequency again. In order to calculate the relative or proportion of pocket pickers, we would need to add up all the offenses here, which we've already been told was 642 records. So to calculate pocket picking relative frequency, we're going to take 4 divided by 642, and we end up with 0.006. Purse snatching is similar. 6 divided by 642 is equal to 0.009. I'm going to complete the rest of the table for relative frequency. So here's the completed relative frequency. I just divided each of the categories by the total number, and I have my relative frequencies. Now, relative frequency is really another name for a probability model. Remember, we define probability as the number of ways the event could occur out of all the possible outcomes. Same thing here. There are 4 events of pocket picking out of 642 total offenses. That tells me then that this relative frequency is also considered a probability model. So we're just basically changing the name and calling a relative frequency a probability model. Now for the second part of this question, we're asked to identify whether or not purse snatching was unusual. So is the probability of someone committing this theft by purse snatching an unusual event? We've defined unusual before, maybe, that anytime we think of something being unusual, that's going to be 5% or less. So any occurrence that happens 5% or less of the time is considered to be unusual. So purse snatching, if we look at purse snatching here, purse snatching occurs 0.009 or 0.9%, move the decimal 2 places to the right, 0.9% of the time. 0.9% is obviously less than 5% of the time, so yes, it is unusual for you to have some sort of theft by purse snatching. How about bicycle larcenies? So theft of bicycles. Let's look down here at the bicycle row. Bicycle probability is 0.065. Let's change that into a percentage. That's going to be 6.5%, which is not less than 5%. So this would be considered not unusual theft. So we can use our probability model to be able to determine when things are unusual or usual.